Hello, my name is Kirby Cravens. My project is Menu Creator. And the main purpose of this project is to create an automated menu creator for Ordered Up Technologies. Order Up is a technology company that empowers restaurants to operate more efficiently and safely by providing diners with a contactless ordering and payment platform. Think DoorDash, but for in-restaurant dining. A crucial piece of the service is the menu. The menu is where diners see what items are available to order and where they add items to their shopping cart. Today, OrderUp creates menus in a manual manner by making API calls directly through their Simple Menu API. The Simple Menu API consists of methods to create each part of the menu. These parts include the merchant, which is the important information of the restaurant which the service is for, the menu, which is the name of each menu the restaurant has, since the restaurant could have a different menu for breakfast and lunch, the categories, which are the type of food they have. For example, the category could be appetizers, the items, which is each food item they sell, and lastly, modifiers, which are the add-ons or removals for each item. This is a time-consuming and inefficient process, and the scope of this project is to create tooling to make menu creation simple enough for someone with no programming experience to do so. We'll be retrieving restaurant information using SteveZ API. SteveZ is a web scraping tool that gathers information from many different sites. For this project, we'll be using it to scrape restaurant information from Grubhub. This information is crucial to the automation process since manually entering data is not an option. For my first architecture, I'll be doing batch sequential. The diagram begins with input from AWS Lambda console. That is where the project is currently running, so the menu creator is currently started using the command line. The input for the menu creator is the restaurant ID from Grubhub. The program takes this ID along with the authentication token from our SteveZ account and makes an HTTP request to the SteveZ API. What we get in return is a JSON object that must be parsed. This JSON response is passed through the parse data component so that we can effectively extract certain information from it. The get merchant component uses various information from the parsed data, such as restaurant name, and makes an HTTP request to the Simple Menu API, which can be seen as the big component in the middle of the diagram. The Simple Menu then creates a merchant ID and returns it to the program. This merchant ID is then used in the get menu ID component along with certain information from the parsed data from before. Another HTTP request is then made and Simple Menu returns a menu ID. Both the merchant ID and the menu ID are used in the creation of the category IDs. This sequential process continues with the get modifier IDs component and ends on the right side of the diagram when the get item IDs component makes a request to the Simple Menu API and retrieves each item ID. The sequential process of getting one type of ID at a time is very important because each part of the final menu is related. Item IDs were achieved last because they are related to every other part of the menu. Each item in the menu contains certain modifiers and is organized into a certain category. For example, a turkey sandwich could have the modifier of add lettuce and could be in the category sandwiches. This category also belongs to a certain menu, and that menu belongs to a certain merchant. After the automated menu creator process is complete, the Simple Menu contains enough information about the restaurant for OrderUp's user interface to show a full menu. OrderUp has its own UI that retrieves necessary information stored in their Simple Menu API so that updating menu is easy. However, the sequential process described by this diagram uses Simple Menu to make the creation process easy. In the class diagram for the first architecture, each component of the automated menu creator has its own class. Each class has private variables that are necessary to make their respective HTTP requests, either to SteveZ or OrderUp Simple Menu. The functions in each of these classes use these private variables to execute those requests. The createData class is connected to the parseData class, which then passes its output to the merchant class so that the automated process can begin. The rest of the classes in the program are connected together by the Simple Menu class. Then, the user interface at the bottom, also made by OrderUp, connects to the Simple Menu class so the menu can be shown to the customer. Each of the components within the automated menu creator map one-to-one to their own class. The components made by OrderUp are grouped together by UI and Simple Menu. Each of these groups are represented by one class each. Each of the HTTP requests in the architecture diagram are represented as the class functions in the class diagram. All of the data paths between Simple Menu and the Menu Creator are shown as the arrows that connect the Simple Menu class to the Menu Creator classes. The second architecture for this project is event-based architecture. This diagram has many of the same components as the first, such as the Simple Menu component, the OrderUp UI components, and the SteveZ component. The Menu Creator components are similar, however have slightly different functionality since they are connected together by an event bus. The automation process is again started by the AWS console, however the rest of the components are started by the event bus. The bus alerts each component when the previous step in the process is done so that they may begin. The event bus passes the output from the previous step to the next one so that a similar control process is achieved. When each component wants to make an HTTP request to the Simple Menu API, it has done so through the event bus. That is why there is only one HTTP request connector to the Simple Menu. However, there will still be more than one type of request. Each request is done when a certain component alerts the event bus that it is time to do so. When the request is made, a certain ID is returned from Simple Menu to the bus and is then sent to the next step in the process. Again, OrderUp accesses Simple Menu for the final output so that it can be displayed on their user interface. All classes from the first class diagram are in this one as well. However, there is a new class just for the event bus. Also, the classes for the Menu Creator contain slightly different functions since the HTTP requests are made by the event bus. All classes are connected with arrows to the event bus and are not connected to the Simple Menu class like they were in the first class diagram. The OrderUp classes remain unchanged from the first diagram. Each component is again one-to-one mapped to its own class like they were in the first architecture. The mapping between the two architectures is the same except with the addition of the event bus, which is mapped to its own class. Here, there is only one HTTP request to map since they are all made by the event bus. The connectors from the Menu Creator components to the bus are mapped with functions in each of the classes. The connectors from the bus to the Menu Creator components are mapped with the event bus functions. The output from the Simple Menu to the bus is mapped by the arrow that connects them. The advantages of a batch sequential architecture are that subsystems within the architecture can be simply divided and are independent of other subsystems. Also, each subsystem transforms input data and produces output data independent of the other subsystems. The disadvantages are that since the process is sequential, each batch must complete before the next one can begin, which could produce high latency. Also, this architecture does not provide for an interactive interface. The advantages of an event-based architecture are that it allows for communication between components that are independent of each other. The disadvantages are that the components are highly dependent on the event bus. For my selection, I'll be choosing the batch sequential architecture. I believe this architecture works better for the project because the automation process execution can only be made to execute sequentially. This is due to the way that OrderUp made their Simple Menu API. For a menu to be created, there must have been a merchant created first. For an item to be created, every other part of the menu must have been created beforehand. Thus, the best way to go about automating their menu creation is to do it one step at a time, so that the output from the first step is sent to the following step, and so on. A big disadvantage of this architecture is that it does not allow for an interactive interface, but that is not a goal of the project. The main goal is to make it simple enough for anyone to use. All that is needed to create a menu is the restaurant ID, and then the program takes care of the rest. Here, the code is ran on AWS Lambda, and we are reviewing the execution results. We printed out a status code of 200 and the merchant ID received from the Simple Menu. When running the code, we can set up a test event that sends the program a menu ID. For this example, we'll be using Thai restaurant. After the program is finished, multiple things have been returned to us from the Simple Menu, and some of these are printed in the function logs here on the right. The IDs are returned to us as paths, with the merchant that they are related to and their own ID at the end. Here's the final output that is created through OrderUp's user interface, but since the restaurant only has one menu, this page is not very populated. As for the categories, you can see all the categories from the menu listed on the left. Within each category, important information is listed, such as the description, the menu that it is related to, and the items it is related to. On the items page, all the items are listed with each of their prices. When you select on an item, you can see an image, its price and tax, description, the modifiers that can add on to the item, and the categories it is organized in. Lastly, the modifiers page. It includes every type of modifier that can be found on the menu and the items those modifiers can add on to. Additional options for modifiers can be seen, such as requiring modifiers and how many modifiers a customer could select. That is the full menu that the automated menu creator can make, and that is my presentation. Thank you for listening.